So in relation data model, which one of the following statements is true. A relation with only two attributes is always in BCNF. If all attributes of the relation are prime attributes, then the relation is in BCNF. Every relation at least one non-prime attribute. BCNF decomposition preserves functional dependencies. So here A will be true, will be A is true. Uh, so any relation with two attributes is always in BCNF. And if all the prime attributes, then relation always in 3NF, but it may or may not be in BCNF. Consider a relation of A, B, C, D, E with the following three functional dependencies. AB implies C, DC implies D, C implies E. The number of superkeys in this relation are, so here the number of superkeys will be 8. When we find, when we are finding the relation, so therefore superkeys of the relation is equal to 2 to the power total number of attributes in relation minus total number of attributes in each key. So there are five in the total relations, and in each key there are two. So 2 to the power 3 will be 8. This section, so in this section, P of uh, probability that A is greater than 10 is 10 by 50, because in 6 to 10, 20, uh, there are 10 numbers greater than 10 and 5 numbers less than 10. So the final probability will be 2 by 3. And in P, B equal to 18 is 1 by 20, because in 1 to 20 there is only 118. So when we take the intersection of these two probabilities, we will multiply. So we will get 1 by 30. And then we will be, when we will take the union, we will add the probabilities and subtract the intersection, because we have taken it twice. And then we will get the final probability of the union. Then for estimating the number of tuples, we'll multiply the probability with the number of tuples in the relational database. Which of one of the following statements are true? So D is true here, because the relation schema R, if a relation schema R is in 3NF, if there is non-trivial functional dependency in the form X implies A holds, then either X is super key or A is a prime attribute of R. So A must be a prime attribute. Which one of the following functional dependencies hold for relation R of ABC and F of BD, where B implies A and A implies C? The relation R contains 200 tuples and relation S contains 100 tuples. What is the maximum number of tuples possible in the natural join R natural join S? So from the given set, we can observe that B is the candidate here to R. So all 200 values of B must be unique in R. There is no functional dependency given for S. So to take to get the maximum number of tuples in output, there can be two possibilities for us. First one will be all 100 possible values of B in S are same, or all 100 values of B and S are different. Uh, which one of the following is not a part of acid properties of database transaction? So the four uh, the acid properties are atomicity, consistency, isolation, and durability. So deadlock freedom is not the part of acid properties. Consider the following transaction involving two banks account X and Y. Read X equal to X minus 50. Write X. Read Y colon equal to Y plus 50. Write Y. The constant that sum of the accounts should remain constant is that of it will be consistency. Consider the relation P of X of P, Q, R, S, T, and U with the following set of functional dependencies. F, P, R implies S and T, P, S, U implies Q and R. Which of the following trivial functional dependency in F plus and where F plus is closure of F? So when F plus is closure of F, we will get trivial functional dependency in F will be C, P, S implies S. Given the following statements, S1 early table with two single value attributes as 1F, NF, 2NF, 3NF, and BCNF. S2, AB implies C, D implies E, E implies C, and minimal cover for the set of functional dependency. AB implies C, D implies E, A implies B implies E, E implies C, which one following is correct. So S1 will be true and S2 will be false. The maximum number of super keys for relation schema are of E, F, G, H with E, S, P is. So the number of super keys will be 8 because E will be a key, it will always be a key. So the number of super keys will be 2 to the power 3, which is 8. Following functional dependencies hold for relation R, T, B, C, and S, B, D, B implies A and E implies C. The relation R contains 200 people and the relation S contains 100 people. What is the maximum number of possible for natural join R natural join S? It will be 100. Assume that in supply relation about each supplier and each state within the city has a unique name and S name from a city from the candidate fee. No other functional dependencies are implied other than those implied by primary and candidate fee, which is schema will be in BCN. Consider the relational schema R ABC. If A implies B, B implies C are functional dependencies on R, then which one of the following is considered candidate key? So it will be D. Relation R with associated set functional dependency F is decomposed into BSI. The redundancy arising out of functional dependency in the resulting set is it will be 0. It is 0 because the arising from the dependency in the relational decomposed into BCNF is 0. When the relational schema is in BCN, all redundancy based on functional dependency has been eliminated. Also, other types of redundancy may exist. This means the resulting set of the relational after decomposition into BCNF, there is no redundancy due to functional dependency. R of ABCD is a relation which of the following does not have lossless join dependency present BCNF decomposition. So the answer is AB implies C and C implies AB. So here B in the first option A if we consider AB and BCD. So both B is the key of second and hence decomposition is lossless. And in the B, AB and BC and CD, B is the key of second and C is the key of third, hence lossless. C is key of in the third case, C is the key of second, but C lies a violent PCN condition in ABC as C is not a key. We cannot decompose ABC further as AB implies C dependency would be lost. And in D, it is already a BCNF, therefore C is the answer. Thank you.